There
Here we
it is.
go. Okay. So it says, question. Find cosine of, well, I don't get this, but I think I do. She uses alpha and little a intermittently, so it means the same thing, I think. So find the cosine of alpha divided by 2, given that sine of alpha equals 3 divided by 5, and that alpha is between pi halves and pi. What is the question? What is the question asking you to find? Angle or side length? I believe angle because alpha is an angle. Begin by writing the.
Well, hold on. No, I think it's asking for a side. Like, because I thought it was asking for cosine of A. I thought it was asking for A. Because we know what sine alpha is, because it's 3 over 5, but we don't know what cosine A is. Cosine A divided by 2.
And then we
That was
said,
my affirmation. But I mean, I that's just what I assumed because when it said alpha, we already are given what alpha is. It's just 3 divided by 2 or 3 divided by 5.
well, sine of alpha, but yes.
Right. And so the only thing that we don't have a full equation for is A, is the side.
Yeah,
I agree.
sounds good to me. So it says begin by writing the identity for cosine of alpha divided by 2. Cosine of alpha. So cosine of alpha divided by 2. Or a divided by 2 in general is the root of 1 plus cosine of a divided by 2. In order to find cosine of a divided by 2, what do you still need to know? I think you just hit the nail on the head. The side. The side length a. No, wait.
No, because that's what we're trying to find out.
What do we still need to know?
Well, we have alpha, right?
Yes.
So if it's cosine alpha divided by 2, what do we still need to know?
It says, will drawing a triangle help you find the missing piece? Draw a triangle in the correct quadrant and find the side.
Find the third side. So, do we need another side? Because we have the angle, and then we found one side. Would we need the second side to be able to find the third side?
Well, yeah, if you're doing the Pythagorean theorem.
I feel like we either need another side or we either need another angle.
Well, if it's a right triangle, though, like this is showing.
Oh, no, I drew that triangle in.
Oh, okay. I was going to say, okay, never mind then. So I was going to say, if we have a right triangle, then we already know 2 of the angles. But so we either need another angle or another side. So I'd probably say I'd just put one of those in. So we have one side and one angle, right? So we either need one or the other.
Yeah, true. One side or another. Yeah, yeah. No, because if I have another angle, then it could be any side still. So I just think it's one more.
Well, but if you get 2 angles, you can figure out the third angle,
Oh,
and then you can use whatever angle you need to solve for all the sides.
duh. It says, will drawing a triangle help you find the missing piece? Draw a triangle in the correct quadrant and find the third side. We know it's between pi halves, which is 90 degrees, and pi, which is 180 degrees. So this is the correct quadrant. By substitution, you should be able to find cosine of a divided by 2. Say what?
Because pi over 4 is less than alpha over 2, which is less than pi over 2. So we should have found that cosine alpha over 2 equals 1 over the square root of 10.
Correct.
Well, then they. Oh, wait.
That's just the answer. This is the first question.
So she gave us all the steps then, essentially.
Yes, the first and the last question are guided questions. But the middle two are not, which I already did. So, yay, lucky us. The question is, sine of A equals 3/5. So this equals 3/5. We know that. We know that's 90, and we know we can find out the angle, this angle right here. Okay, that makes sense. Does that make sense to everybody?
Could you say it one more time?
So we have sine of angle A is 3/5. And we know this is sine right here because it's the y value. So I know that that'd be 3/5. And
That's that sine A we agreed was this angle, right?
maybe not then.
Yeah, so the sine of alpha is 3/5.
So this angle is 3/5. Yeah.
Yeah.
Okay, and then you have a 90 degree here. And then you can figure out that angle.
By substitution, we should now be able to find cosine of alpha over 2. So if we actually put in 3/5 divided by 2, cosine 3/5, would that put out the 1 over the square root of 10? Or is,
Yeah, I think that's the idea.
well, because one's an alpha sign and one's an A sign, right? Or are they both supposed to be alpha?
I don't know. That's how she put the problem though.
Huh.
If you had the three angles, you could solve the triangle, could you not?
Yeah.
True. But if she wanted us to solve it this way, which I think she does, we'd first have to find the cosine of A. Or alpha, I think. How would we go about doing that? Could we do sine inverse of 3/5 to find out what alpha equals? Then
that's what I was thinking. So we know the answer is 3/5. So if we take sine inverse of 3/5, that'll give us what A is, or alpha is.
And then you could plug that in for A and then get that. Okay.
Yeah.
That makes sense to me. Does that make sense to you guys?
Yeah.
Si, senor.
Did you serve in a Spanish-speaking mission? Just curious.
No.
Oh, wah. Okay. This one I was more sure about. This one not so. I was doing the same thing.
Find sine A plus B given that sine A equals -3/5 and is in the fourth quadrant, and cosine B is -1/3 is in the third quadrant.
So I took sine of inverse of -3/5 and got that. Cosine inverse of -1/3 equals a positive 109.47, but we know that it's cosine, which is the x value, and it's in the third quadrant, so it has to be negative. So I added those together, put that, and then that's what I got. Negative point. So that makes sense, I guess.
Clutch.
This one, I remember going to the tutoring center last semester when I took this class, and they gave me a sheet of all those identities. So that's how I did this one.
Do you still have all the identities? The sheet?
I don't. I had to look them up this time.
Dang.
They have them on Wikipedia though, or any other website you please.
Right.
And it's kind of like just learning a new language. You have just pure memorization.
I hate that. I hated learning a new language.
What new language did you learn?
Portuguese.
Oh, right. Did you serve in Brazil or Portugal?
Brazil.
What part?
São Paulo.
Sao Paulo. Nice.
What years did you serve?
14 through 16.
Never mind. I had a friend, Matt Doggett, who served there, Sao Paulo.
You had a friend who?
His name was Matt Doggett. He served there too.
Matt Dog?
Matt Doggett.
Oh, Matt Doggett. I thought you said like Mad Dog, like Cat Dog, but Matt Dog.
That's what we call him on the streets, anyway.
Oh, man, though. I served my mission 2014 to 2016. But that's... So we might have met each other in the MTC somewhere. But then...
Because I was in the Brazilian MTC.
Are you in the Brazilian MTC? No way, then.
Yeah.
Shame.
Well, you might have met my wife. She went into the MTC the same day as I did, but the Provo one.
Do you remember her name?
I do know her name. It would be Sister Wagner.
Sister Wagner.
I do know her name.
Wow. What a dumb question.
That's funny.
Do you know when did you go to the MTC?
I went to the MTC July 30th of 2014.
No freaking way. We went in the MTC June 23rd.
But that was in the time when the MTC wasn't
July 23rd. It was July 23rd or July 21st, July 23rd, one of those days.
But that was the days when the MTC wasn't expanded yet, so they put all the Spanish elders in leftover BYU Provo housing because everybody left at once. So
that's freaking nuts.
That was interesting experience. Okay. The last verification problem will be done through guided instruction. Be sure that each team member is confident in each step. Sine of 3x equals sine x times 3 cosine of 2x minus sine squared x. I bet you those are squared. But let me just check to make sure. Yeah, they are. I thought so. Did you guys hear anything from Sister Hess about what we're about to do for Thanksgiving?
No, I emailed her my concerns and I said, I know we had to combine both Google Hangouts on Tuesday.
Yeah.
But I wasn't sure. Like, I was concerned about the exam, and she said that we do have an exam next week, but she's pushing the due date to Monday.
Okay, I guess. That makes sense.
Why? What? Did you hear anything about her?
No, I didn't. So I was just wondering.
No, yeah, she emailed me and she said, unfortunately, we do have an exam, but she's pushing the due date to next Monday. So you can procrastinate until Monday if you wanted to, which I probably will.
It's the way to do it right there.
Okay, that makes sense.
But just letting you guys know, it might be difficult for me to get on and do the Google Hangout next Tuesday because I'm leaving for Alaska on Saturday.
Okay.
Are you driving there?
No.
It's a fun drive.
I want to be there for more than a week if I'm going to drive there.
It's a fun drive. Alrighty. Should we continue on now?
Yeah.
Okay.
Nice digression for a little bit.
Okay, the first strategy or verification is to work the more complicated side. For most students, the right-handed side looks more complicated, but in actuality, the left side is is the side to work because there are identities that can be used. How can we write these identity? How can we rewrite so that we can use an identity? Wow.
You just move sign over, right?
Let's see what she
Or
says.
is that no? That's a negative sign. That's in that you're multiplying negative sign.
Well, it says, but at this point, you should have a sine 2x on the left side, right?
Well, this is how she claimed to do it.
Sine 2x. Using substitution, we can get rid of both of these functions.
So sine of 3x equals sine x, whatever that. Now sine 3x squared x minus sine squared x. Sine of 2x plus x, which also equals that. That's what it did originally. So sine of 3 cosine squared x. Missed one. Minus sine squared x will come out to be that.
Is that a negative sine squared x in the original problem, or like are you subtracting it or multiplying by a negative?
I think that's just a yeah, it's just a subtraction.
Just a subtraction.
Mm-hmm.
Wait, why is there two equal signs?
Oh, she did it really confusing. So this first thing is the first part of the equal sign in the beginning. That's that. And then this part at the end is that. But in essence,
so she's just saying sine 3x equals the sine x times 3 cosine 2x, that whole thing.
this is supposed to say that this is what this is supposed to equal. Sine of x, which
I'm quite confused with that.
Because if you narrow it down even farther, this is the same thing as this. So this is what's in question. Where'd she pull that from?
Did she just divide it out? Because if you have, well, it would be sine over sine, which I don't think would get us cosine 2x.
Well, you can combine the two signs on the right side of the equation.
Let's see. As a team, oh, just kidding. Let me look up those identities so we can actually know what we're doing. That might be a good idea.
Hey, side note again. I just checked iLearn to go look at the extension problems that we're doing to see like how she worded it or whatever. And I just got back my grade for the written portion of the exam.
Uh-huh.
And I got a 70 on it, which is good. And it brought my final grade up 2 points.
Yay.
I'm not failing yet, but I'm 2 points further away from failing now, even though I got a 70. That just goes to show you how bad my exam score was.
Oh my. So if you look at the, I don't know why mine turned out this color. I'll show you. I don't know why my page turned out to be this color, but it's kind of hard to read. But this is what she has for the, oh no, it turned out green. But she has this one that we're missing, this equation here, which is I think where she broke it down at. Because instead of sine 3x, she simplified it down into the sine 2x plus x, which is the one we're wondering about. And so what happened is I think when you copied this and this, it put it up here.
That makes
Oh,
I was wondering where, like, I was wondering how she got this sine 2x plus x on the right.
Yeah, so she simplified sine 3x down into sine 2x plus x because she just took out an x apparently.
there we go.
And then that equals sine x times 3x minus sine 3x.
That makes sense. That makes.
And then she took out the 2x and made it the sine x and cosine 2x by substitution. I have no idea. I don't know where she got all this mumbo jumbo from. I don't have a very good feeling about this upcoming exam with these substitutions.
Yeah.
So, well, if we get, because this one will verify and simplify down to this one, right? Regardless of how she did it. But using substitution, we can get rid of both of those functions. So this is what she had, sine 2x and a cosine 2x. Then she used substitution to get rid of them, even though they're right there. I don't know.
How do we have a sine 2x and a cosine 2x?
I'm just trying to figure out substitution. Because the substitution of sine is what? How would we substitute cosine into sine? Let's see, what are the... Trigonometric identities.
Well, for the sine, there's a formula that I'm looking at where if you have two or sine 2 of an angle, then it'd be 2 sine angle times cosine angle. But we have sine 2x plus x, not just sine 2x.
So if it's so sine squared theta plus cosine squared theta equals 1. That helps me out none at all. I don't know where she got cosine from, because even if you use the sine reciprocal identity, it's 1 over cosecant, right? Do we have Sal? Will Sal help us?
Um, I okay, so I know you guys hate it when I look at the answers, but I was on the right track with the identity saying, um, let's see, sine 2 theta is equal to 2 sine theta times cosine theta. What the heck?
That's the answer that they got? No, you covered the answers.
Sorry about that. Do it again. What were you saying about how you're on the right track?
Oh, with sine 2 theta is equal to 2 sine theta times cosine theta.
Oh, right. You're right.
So we have sine 2x plus x. So it would be sine 2x times cosine x.
Sine of what?
Sine 2, okay, so 2 sine x
Huh?
times cosine x.
Uh-huh.
But then you have that extra x. So I don't know if you put that in a parentheses like cosine x of x.
Maybe. I should have done that.
There's a sin x and a equal sin x. Could we just divide that sin x out?
What do you mean?
Well, I don't know if you can't, because you see at the very end of the first problem, you have sin x equals sin x times 3 cosine. Could you just divide that sin x out and get rid of it? Well, I don't think so, because you'd have to divide the entire thing by sin x. Which might work, because we have a lot of sin x's, but I don't know.
Well, no, I think you could. Because in the second side of the equation, you have a sin x times 3 cosine squared x. No, minus sin x sine squared x. I don't know how you would do that.
I don't either.
Okay. My backpack's in here. I'm gonna. Okay. Okay. So yeah. Sine x cosine. No, 3 cosine. Squared. Minus sine squared x. Okay.
Oops. Sorry.
Well, I don't know if this would, I don't even know if this is right or not, but
Try something real quick.
here's what this came up with, is they did the right side instead of trying to work on the left side.
Yeah. Are you talking about symbol lab?
Yeah.
That's what I'm trying to do right now. So
And what they did is they distributed this out. So let's see, they expanded the, what did they do? Here's where they had it, the original.
I think you should
Then they
pull.
expanded, oh, so they just took the negative sign out. So they moved this one over here, added that one, and then had sin x, which is what gave them this equation. And then somehow they dropped drop to 3 there? To 2? Maybe that's a typo. So that's still 2 there. And they distributed the parentheses to sine negative sine squared x plus sine x times 3 cosine 2x.
What? Wait, why do you have that three in the exponent?
Right here.
Yeah.
I think that was just an accidental typo because they use 2's everywhere else. Because even down here where they have it, it's back to a 2. So I think that was just a typo up there. Because see, it's right here. It's a 2 instead. And then I just rearranged it.
Well, I think she's only wanting the left side for now. Like in the part that we're doing in the
Yeah, about there. Out there, man. About there. Oops. I'm about there, man. About there.
Oh, crap.
So what we're trying to do right now, oh, I see what she did. What we're trying to do right now is just we're not even dealing with the right side of the equation. We're just trying to get the left side of the equation to look like it does after it says, or before it says finish the verification. Like that's what it's supposed to look. That's what we're trying to get sine 2x plus x is. Does that make sense? We're trying to get sine 2x plus x equal to 2 sine x times cosine squared x plus cosine squared x minus sine.
But those aren't equal, are they?
Do what?
Those aren't equal, though, right?
Well, they are.
These ones? Yeah.
But you have a 2 sine x. I don't know. I'm not very good at these.
So it's the same verification that we were just doing.
Sure.
Because sine, what is it? Sine 2x is equal to 2 sine x times cosine x. And then we have the extra x, so that just goes onto the cosine.
Say what?
So it's 2 sine x times cosine squared x. I know how we got that, but I don't understand the cosine squared minus x minus sine x squared times sine x.
Are you talking about this half of it?
No, the half on the left side that's not highlighted.
Oh, right here?
Yeah, I don't know how we got that. Because I understand how we got the first part.
Good question. Good question. I don't know.
Like I have absolutely no clue how they got the cosine squared x minus sine squared x.
Oh, so what they did is they simplified the whole left side down that she gave us into 3 sine x cosine squared x minus sine third x. And then that equals the right-hand side. So we're just trying to simplify it down from the 2 sine x cosine squared x plus cosine squared x, that thing, down into 3 sine x cosine squared x minus sine cubed x. Which, if you multiply the sine x through, then that would get you your sine x cosine squared x minus sine x cubed. But I don't know where they got the 3 sine x from. Does that make sense? Is everybody on board with that?
Sort of.
Yeah, we'll see if I can't. I don't know if this helps, but we'll screen share. So this is what we're supposed to get for the final answer. This line right here. And so what they did is, if you look at this one here, all they did was multiply the sine x through. So they multiplied sine x through, which got them down to this line, which got them this, sine x times cosine squared x minus sine x cubed. So they got rid of that one. And then here, they have sine x times cosine squared x, which if you multiply those out, there's an invisible, well, no, because that's an invisible 1. So 2 times, I don't know where they got the 3 sine x. But if you multiply those together, you get sine x times cosine squared x. I just don't know where they got the 3 from. Because they didn't substitute anything. They multiplied that by that and that by that, and then somehow got a 3 there. Because then once they did that, that equals the right side. So I understand how they got from here, from this, down to this, but I don't know where the 3 came from. That's the only thing I'm confused about.
The 3. You have 2 sine x.
Is 2 sine x times cosine squared x, does that in a calculator give you 3 sine x cosine squared x?
Oh, I see why. So all they did was they just added, like if you substitute sine x cosine squared x for 1, then you basically have 2 plus 1. So it would just be, because all you're doing is combining like terms. Sine x cosine squared x is a like term, and you're adding it to itself. So you have 2 of them. Now you have 3 of them.
Oh, you're right. That makes perfect sense. Yep. Uh-huh. Yep.
Still don't like it.
I don't either, but it works. It works.
So so what they did is, since sine x cosine squared x equals 1, they added them, but then where'd they get the cosine x back at? You know what I'm saying?
Would you ask?
Because I understand, like you said, that formula that you just gave gives you 1 when you do it, when you do the multiplication out. But how'd they put sine x and cosine squared x back in if they had substituted that for 1?
What do you mean sine x, cosine squared x?
To get the 3, right? That's what we were talking about.
Well, they didn't necessarily substitute, but it was so they're just combining like terms. So you have
So essentially, you can just imagine that there's a 1 in front of that. Is what you're saying?
yeah,
Mm-hmm.
And then they just added it.
yes, because they have
Yep.
2 sine x plus cosine squared x plus 1 sine x plus cosine squared x,
Okay.
which will just give you 3 sine x cosine squared x. And then
Kind of.
they took a sine x out of it, which would give you sine x, and then 3 cosine 2x minus cosine squared x, which is what they have on the right side of the freaking equation the whole time.
Yep.
Yep.
Who even deals with identities in their everyday life besides like calculus professors in college?
Nobody. Just kidding. It's probably a really vital thing for like rocket ships or something.
I hope so.
It's probably really useful in other math departments.
Guess what we get to do, guys?
The group quiz.
Lovely quiz.
Yep.
Don't worry, it's only all substitution.
Good, because that's all that I don't know how to do.
Woohoo. Which is only 4 problems. Darn it.
It's only 4 problems.
Yes.
But it's only 4 substitution problems.
All right.
Oh. Simplify the following trigonometric expressions.
So let's see here.
Jeez.
This is easy. We understand it. There's no problem. Got it.
Okay.
Confidence is key. That's all I gotta say.
Like, what am I confident about? Like, I'm confident about my lack of knowledge on this topic.
No, you're confident and you know how to do it, even though you don't quite understand how to do it.
That we'll go with that, sure.
You're welcome.
So we've got sine x.
Maybe not.
Over 1 minus.
Sine.
So 1 minus cosine x is an identity. I know that.
Yes, it is.
Which identity is it?
I don't remember. Let me think.
Is it 1 minus or 1 plus?
1 minus.
So dang it.
Dang it.
Why do they always throw a curveball at you?
Like, this is a quiz. It's supposed to help my grade, not prove how much I don't know it. I already know that.
Frustrating.
Okay, so if we simplify this following equation, that's so simple, so easy.
Okay.
So I've got.
Why did you reverse it?
Oh, I was doing it for this one. Guess I should have done the first one.
So sine x over 1 minus cosine x. That's got to be equal to something, right?
So sine x over 1 plus cosine x is tangent. It's actually tangent to theta. No, tangent theta over 2. That's what it is.
Cotangent over.
Tangent theta over 2.
The frick.
I decay.
Oh. Duh. It can't be that simple. Use cotangent of x. Oh.
So sine x over. You know, I'm looking at an entire chart of these, and none of them have any of these. So I don't understand how to like substitute when I don't see what I'm supposed to be substituting. You know?
Yup.
I have the same issue.
Like I've got a chart, but none of them are showing me what is sine x over cosine x. You've got like cosecant, which is 1 over sine x, and you've got secant, which is 1 over cosine x, but there's no. So I really am trying to understand this. I'm just
Sure.
not doing it. Well, the law of sine says that AO is over sine A,
Ew.
B is over sine B.
Oh.
Did we ever figure out what it was? So I had to do something real quick.
Somewhat.
Are all of those questions of number 1?
We have to put. Let me make that more clear.
Okay. So how are you doing that?
Okay.
Are you able to just inverse that like that? The second part, 1 minus cosine x over sine x?
Say what?
So the original problem is sine x over 1 minus cosine x, but the third step down, you have the opposite. One above that. Yeah.
Oh, that's just this.
Oh.
The ad was inappropriate.
What was
On my screen.
what was on your screen?
I just hate ads, so I always say they're inappropriate, and then it never shows them again.
I missed it.
There was an ad that was showing up and said, "Don't show this ad again." And his excuse was it was inappropriate.
Oh. Oh.
Inappropriate to what we're doing anyway.
Yeah, it's irrelevant. I just want to see if this will help us out, because I am really struggling, and the only way I learn is by like somebody actually showing me how to do it.
For real though.
Okay.
That's not that. Okay, there it is.
It changes. It'll probably say, I can't solve this.
It always does. I'll be there when the wood stops turning.
If it doesn't, you should put more parentheses in it. I hear parentheses always helps.
Keep blocking it off. It's taking too long. It's going to say it can't.
Oh.
Oh. Wait. It's not my input. I don't think that's right. That does not look simplified. In fact, it actually looks more unsimplified.
Yeah, that's what I'm getting on another website too. Same thing. It just looks way too complicated. But maybe not. No. Maybe that is what they want, though. I don't know.
I can't imagine that simplifying it would make it look more complicated. That just doesn't make sense to me. Hmm. What the heck is going on here?
Oh my gosh. that make sense to everybody? That even seem logical?
Oh, well, that one looks nice. But I don't know how they did it.
It makes sense, I guess, in a roundabout way. Because if you take sine divided by negative 1 minus cosine of x,
Well, I put this into like multiple calculators, and they get 2 cosecant x when it's all simplified. But
2 cos.
I don't know how they get it. So I've gotten that same answer 3 times, so I'm assuming that's probably the right one, but I don't know how they get there.
I have no idea. Yes.
Oh my goodness gracious. What did you say those?
You muted, Chris.
What did it say those calculators were giving you the answer as?
They both came out as 2 cosecant, so 2 CSC times x. So like in parentheses x.
Oh, right.
That's what they came out with for this, but I don't. I have no idea.
Mm-hmm. Starting out the beginning.
Oh, maybe it's because if you expand the form, so if you expand sine x over 1 minus cosine x, you'd get negative cotangent x plus cosecant x, and then you'd get a positive one for that. So, and then for the other side, you'd get positive cotangent x plus a cosecant x again, which would then get you your 2 cosecants.
Yes, that's what I have right there.
Well, what I think, using yours as well, I think that sine x over 1 minus cosine x could also be written as negative cotangent x
Yes.
plus cosecant x. And then since the other one is opposite, it would be positive cotangent x plus a cosecant x as well. which would get you your 2 cosecants.
So okay, so this one, the top one here. How would you make that a positive? Make
Well,
that
I think that's just, I'm just trying to figure it out, but I think that's what they did here is they made it so 1 minus cosine x is equal to cosine x, or cosecant x, excuse me. And then sine over x could be equal to a negative cotangent x, because cotangent is 1 over sine x. So if you make it negative, wouldn't it do the inverse, which would then just be the top?
yeah. Yeah. Is that look good?
And you just do the same thing for the other side.
Yeah.
And so you'd have, well, your second line would be, when you simplify them down, it would be a plus, let's see.
Wait a minute. How does it simplify down into cosecant of x?
Because 1 over, or 1 minus cosine x, I think breaks down into cosecant x. Well, it'd be negative cosecant x, but since you have 1 minus, it'd be a positive cosecant x.
So this line actually, oops, just cosecant of x.
This is the lines that I'd have once I broke it down. This would be the first one, which would be your, what is it, 1 over, or this would be sine x. It would break down into negative cotangent x because cotangent is 1 over sine x. So it'd have to be negative in order to get sine x on top. And then, so you'd have sine x over 1, right? Because once you inversed it. And then in order to get to cosine, you do cosecant in the bottom.
Mm-hmm. Hold it right there.
Because in order to get sine x over that, you'd get negative cotangent over, or negative cotangent would equal, well, let's see, negative
Oh yeah, that
cotangent
works. That works. That makes sense to
x
me.
would equal sine x over 1. And then in order to get a negative cosine, you'd have to get cosecant. That's kind of what I'm thinking. Does that make sense? And then you just do the opposite for the other side.
Mm-hmm.
So I don't know. That's kind of what I've got. Or what is it? Cosine. So I need good. Yeah. So that's kind of what I did, but
It
I could
works.
be absolutely 1,000,000,000% wrong. So
Guess we could try the next one. We'll have a little bit more luck on this one.
Sorry guys, my internet is being really bad.
Sure, blame the internet. I'm just kidding.
Squared a minus 1. What the heck?
So what are we trying to do now? Is that the answer to cosecant x?
Yes, we're gonna call that good. Try to move on to the next one. See if I can't.
Tangent A. Tangent alpha times cosecant squared alpha minus 1. I don't think this one has as much to it.
I hope not. Cotangent of a oh gosh.
Where are you getting cotangent from? Can you guys hear me?
Yeah, we're all just trying to figure things out.
So I typed this one into one of the online calculator things because I still have not a clue how to do this. Like nowhere close. And it's just saying you need to multiply the tangent x throughout the parentheses. So you would just have tangent x times cosecant squared x minus tangent x. And that would be the answer.
I feel like you could simplify that answer more, though, couldn't you?
I don't know. I don't know what answer is anymore.
I don't either. Sine over cosine A is 1 over sine squared j minus 1. I mean, that is rewritten, but is that simplified all the way?
Are you asking me or the?
I'm asking Chris.
Okay.
So did yours, you pulled out tangent out of it, and then what'd you get for yours, James?
So, I don't know if there's an easier way to simplify it, but the way that I saw how to do it was just you multiply tangent throughout the entire equation. So it would just be like, it's not a very simplified answer. It's just tangent of alpha times cosecant squared alpha minus tangent of alpha. Yeah, because most of it is just water and Coca-Cola mixed. Do you want me to come look? All right, guys. Sorry, we're. It's been a rough morning, so I'm gonna be right back.
You're good. We can't hear you if you're talking, Chris, just so you know.
I don't know why it keeps doing it. That's so annoying.
I don't either. What's the Pythagorean identities? Because I feel like this one would work with it. So
Would too.
cosecant squared x can be simplified to cotangent squared x plus 1. So you'd have tangent of A times cotangent squared x plus 1 minus 1, so that'd get rid of your 1. I'm grouchy too. Because here's this identity, and so we could probably use this to simplify that in the brackets. Because cosecant squared x equals cotangent squared x plus 1. So then you'd subtract that, get rid of your 1 there.
Say what?
So you'd have tangent of alpha times cotangent squared
Tangent of alpha times
cotangent squared x is essentially what it would be. We have 2 more problems. Why? Sure.
That's simple.
And then I don't know if it's simplified all the way.
Sine over cosine of A cotangent is cosine sine squared.
All right, I'm back, guys. Not that my presence helps at all, but
Oh, good grief.
this is like literally the worst time of the year that we could be talking about this, because this is like the one week that I'd actually want to go to the tutoring center. Is cosecant squared alpha minus 1, is that equal to cotangent?
Yeah.
Well, the cosecant squared alpha equals cotangent squared x plus 1, but the plus and minus 1 just cancel each other out. So now we're just trying to figure out what to do with tangent. Okay.
Can't you just...
It's funny, that's all we keep saying. Can't you just I love it.
Well, I'm wondering, can you just multiply it out? Like, so you'd have sine times cosine over cosine times sine?
I don't know, because there's a squared right there.
What is all this?
That's insanity.
She wasn't even talking about the math, but like I feel like she was speaking to me. So is that, are we sticking with that answer? Sine divided by cosine alpha times cosine?
No. I'm just going to move on, see if...
Is this the entire quiz, or is there another page to it?
No, this is the entire quiz. Think.
Okay. Oh my gosh. Okay. So we just have to get the right side of the equation to equal to 0.
Yippity yippity. hate these so much.
What?
That I hate these so much.
Me too. What the heck? Everyone went mute all at the same time. That was freaky. That was weird. I mean, it still is weird. No one else is unmuted but me.
I'm here. So I don't know if that counts for anything.
There it is. You came unmuted. It like a notification came up in my. Oh, there we go. Oh, now he's muted again.
Hello?
Chris is unmuted.
Hello? Yay!
It was weird. I got a
No
notification that said Taylor muted everybody, and I was like, I
What
didn't
the
even.
heck, Taylor? What the heck, Taylor? What you doing, man? Trying to mute everybody?
He didn't mute me. I'm in
do it.
mute to it.
I was trying to mute myself.
How do you mute everybody but yourself? I didn't know that was a thing.
Oh, gosh. Curse the luck. Yo, man, who's eating cereal in the background, for real?
Who what?
Who's eating cereal in the background?
Nobody. We're trying to figure out so many things right now. We're trying to figure out our plans for Saturday. They're trying to because we're all four of us are going to the airport at separate times. So we're trying to figure out what time we need to leave. They're trying to finish the slow cooker sweet pork, and they're trying to start making cinnamon buns for breakfast.
Ay, ay, ay.
And I got into a car accident on Tuesday, or no, and it wasn't my fault. So I didn't get the other party's insurance. So I've been trying to email the sheriff's office back and forth, and they said that all I had to do was email them the case file, and I did. And they emailed me back an accident report, but it was for the wrong accident on Tuesday. So I think they messed up and switched up case numbers around because each case number should only be with one accident report. So now I've been trying to email the sheriff's office to figure out what the heck is happening so I can get my freaking car fixed.
Yikes.
That's what we have to deal with. All right. So, sorry, go ahead.
Oh, is everybody unmuted? Did we get that problem fixed?
Not Taylor, not Jason.
It's just us two.
Yeah. So I know there's like a total no-no and like complete cheating in the honor code, but I did the math thing again.
Sorry, I'm back.
Okay. I don't have to contribute to this problem if you guys don't want me to, but I'm understanding how to do it.
Totally, go ahead.
Okay. So we know it's the original problem is cotangent x times sine x, right? Minus squared x times secant x. So all we have to do is convert everything into sine and cosine, and it's so easy.
Yes.
So cotangent is just sine over cosine, right?
Am I not screen sharing anymore?
Oh, you are. Wow, that was weird. Yeah, that's it. You got it. Dang.
That was easy, I guess.
I love you.
Those those are veggie straws. Nice.
They are. You got a little hungry.
Did you take a shower?
I just came into the light out of the darkness.
Well, like, and I thought your hair was different too. Like, I thought you, like, when you were muted for like 10 seconds, you just went and took a shower and came back.
No big deal, you know.
You know,
Just,
it'd be that's, just cooling off the brain, trying to figure it out in the shower. That's where I think best.
I think best when I'm in the bathroom, but not necessarily in the shower. All right. 1 minus sine x f.
You try your best, but you don't succeed.
You know, it's kind of weird to me.
They're already equal to each other.
Yeah.
Like, the identities are already equal to each other. Like, I don't know if we're just supposed to.
Oh, dear.
Well, this is just verifying, so you just got to say whether it equals the side or not. So it's true or not true.
I mean, it is true because the 1 minus sine squared x is equal to 1 plus sine negative x. Like, those are already equal.
Uh-huh.
Well, no, they're not equal because 1 minus cosecant negative x is the same thing as 1 plus cosecant, but we don't have 1 plus cosecant. We just have cosecant.
Why?
Am I right or am I wrong?
I think you're right. Let me check, though.
Do you guys ever just, like, sometimes get tired of the honor code?
Do I ever get tired of school in general? Yes, definitely.
Like, my wife and I, we stay up at night sometimes dreaming together about the day that our job is to not go to school and to not come back and do homework and then to not go to another job.
For real.
Our lives will be literally 1/3 of that. Either homework, school, or part-time job.
True.
That's like the dream. I think the American dream has changed from owning your own home to not being in school and being out of debt.
I don't know what the American dream is anymore.
There ain't no dream.
Wow, I didn't know that trig identities just like made everyone depressed.
Hello.
Wait, so cosecant is sine, right? So if we swapped out on the left side, I'm looking at the left side. We swapped out cosecant for negative 1 over sine x. So you'd have the same top, but the bottom would be different.
Sure. Freaking A, man.
I thought he was going to say freaking anus. I was like, wow.
Very frustrating.
Have you seen the new Thor?
No.
And then you'd have +1 on there because you have a negative. So you'd have +1 on the bottom. Oh, you had it. Never mind. You're right. You had it right. Just add your negative back in there. Sorry. And then you'd have sine, and then the x wouldn't be negative anymore. It'd be positive in the parentheses.
There you go.
And then once you simplify that down, I believe, because you have 1 minus sine squared x over basically positive 1 sine x. Then that would just equal you'd multiply that out, right? You'd multiply negative sine x out. So you'd have negative sine x times sine x minus 1.
Negative
So I'm just thinking
sine.
if you multiply your sine out. Yeah, so you'd have negative sine x
Uh-huh.
times sine x minus 1. Because you multiplied it out and it got rid of that. And then if we multiply that back through, because I'm just trying to get rid of that division. So if we multiply that back through, we'd have sine x minus sine squared x, right?
Sine x minus sine squared x. I guess.
Now we just got to get it to equal 1 plus sine negative x over cosecant x.
Mm-hmm.
I think we're pretty close at this, though. Is there any, well, so we have a negative sine x right now, which, according to the table, would equal negative sine x, but I don't know if that would matter at all.
Oh my goodness.
Oh wait, actually, if you use the sine negative x equals negative sine x,
Hold it.
that would,
Hold it.
because you have negative sine squared x, that would actually simplify it down, wouldn't it?
Hold it.
Because that would equal it. That would make them equal each other, I think. I don't know. I don't know where I'm doing it.
I think you may have been on to something. Mm-hmm. Let's try something else.
A great song.
I don't even remember what that's from.
Aladdin.
Oh, right.
Well done.
That chewing, though. Man, that chewing.
Yeah.
Well, there you go.
Woohoo!
That looks equal to me.
Do 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 do. Well, I'm gonna call that good there. That's good here. And what do we want to do about this? Is the question.
75% sounds good to me. Just kidding.
Oh gosh, no.
It's better than the rest of the quizzes we've gotten recently.
Ah.
This
That's
is gonna
nuts.
suck so bad. This test.
Yeah, I'm not too excited about it.
I hope she like drops the lowest 3 test scores.
Oh hala.
All of my other teachers are dropping the lowest test score, like all of them.
Be dope.
So is that what we're going with? Are we going with we're done?
I'm gonna try one more last ditch effort.
Okay. I'd let you.
No, I think we're gonna have to go with that because no,
Was that your last ditched effort?
that's my last ditch effort. No,
Okay.
well, I was trying something real quick, but no, it's not. It was just making it more complicated. Alrighty then, that's them.
All right. Well, that was fun, guys.
Hang on real quick.
We're hanging. I'm hanging, man.
Hang on. Oh, this one's tan squared x. But I found something that's similar to it
Maybe.
that might help us. They got it to equal 1, but that was because it's tan squared x.
Don't.
But what they did here is they made this one into 1 over sine squared x minus 1. And this one I don't think would, well, this would just be sine x over cosine x because it's not squared.
Okay, hold it right there. Hold it right there. Let me try to input this data. So be sine of x over cosine of x. And it'd be, the heck?
It'd be 1 over, it'd be 1 over sine squared x minus 1.
1 over sine squared x minus 1. Oops, let me update that a little bit.
And then if we multiply that out in a different calculator, it might come out to the right thing.
Possibly.
Because we can't use theirs because theirs is squared, but ours isn't. But it looks like they just took the 1 over, what is it? They multiplied the 1 through. No, what'd they do with that negative 1?
What is sine over cosine?
Tangent or cotangent?
So it'd be cotangent of x. I thought you're right. No, it's sine. I mean tangent. Sine over cosine is tangent.
Yeah.
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 You don't want to revert it back to tangent.
No, I'm thinking for the calculator though.
Oh.
And times this nonsense. Well, let's see. Oh.
Sorry, I haven't eaten anything, so I'm snacking a little bit.
No, I've got sweet pork and cinnamon buns waiting for me.
Ah, that's why you're trying to run.
I'm not trying to run. I also have to poop. I'm a trooper.
The other kids with there we go. Lastest effort. Do. No, that was stupid. It led me back to the first thing.
Did it?
Yeah.
This is close. But just because it's not squared, we can't get it to equal 1. Unless it does equal squared. If we check the... no, it's not.
What?
Nothing. I was just checking something real quick. So they did this, then they multiplied the 1 through to get 1 over. So the next step in that one, let's just make it this. The 1 minus sine squared x over sine squared x.
The who?
So on the right-hand side of the equation,
Uh-huh.
where it's 1 over sine squared x minus 1, we can simplify that into the same thing that they did, where it's 1 minus sine squared x over sine squared x.
True. All the other kids pumped up kicks.
It's minus sine squared x over sine squared x.
Over sine squared x, yeah.
And then that can simplify down into cosine squared, just so we're showing our steps. That same thing can simplify to this, where it's cosine squared over x over sine squared of x. So you're right in this equation now.
Except without the square, yeah.
Yeah, without this square on the
yeah.
This
Times
cosine squared.
cosine squared x divided by sine squared x.
Now, can we put that into a calculator, or would that just come out with the same thing?
I hope not. That'd be so annoying, but probably.
Try it.
Let's try it.
Sine squared. I forgot what it was.
Sine of x. X over cosine of x.
That's not right. Oh.
You want the other one to be cosine squared of x divided by cosine squared x over sine squared x. Oh, yeah, it just did the same thing. For goodness sake, man.
Oh, shoot. This one's not. Well, let me see.
Try a different one. All the other kids with
This one came out as cotangent x.
cotangent of x.
If you're looking at my screen.
Let me see your screen. Ooh, Mathway.
I did sine x over cosine x, which I believe is right, and then cosine squared x over sine squared x, and that came out as cotangent x.
Works for me.
So I think that's probably our best bet.
Oh, gosh. Okay. Anything else, guys?
Nope.
Nope.
Ooh, who's that lady?
That's my
Hey.
wife.
Hey, come on.
Stop staring at my wife.
Oh, you know how it said work probs right there?
You guys want to see my wife? There she is. Okay. Sorry about that.
It's all good. So chill.
Anyways, you were saying what about the something?
I think it said like hashtag work probs or something like that. Just
Oh yeah, it was homework probs. That's what it was. Hashtag homework probs.
Where did she work?
For some reason, I swear, instead of probs, I thought it said boobs. So I was like, what the heck?
Did not say that.
It's like, what is your wife?
honestly, like depending on where you work, that's probably a legitimate hashtag. But
Oh my.
I didn't think your wife would be like that. So I was like, what
She's
the?
definitely not. So
all right, are we done?
Yeah, I
Yeah.
think we're done.
All right, sweet man. I'll suffer, and we will all meet on Tuesday.
Yes.
I don't know what you guys' schedule is going to be like on Tuesday. If we're meeting at the same time, I'm gonna have to wake up at like 7 to do this. But we can, that's fine.
Well, Tuesday may. Could we do it like on a different day? Would a different day be better?
What even is the day of Tuesday? The 21st.
So I'm driving down to Arizona, so that I didn't realize we're gonna have to do a 6-hour Skype call on that day.
Do you guys want to try to do it on Monday?
Monday.
Would that be better for everybody or worse?
That would work. Yeah. I can make that work.
Monday at the same time?
Yes.
Okay.
Unless you're wanting to change it for your thing, but
No, that works because Tuesday we're gonna go to a cabin in the middle of this frozen lake. So Monday works.
you'd rather not be doing math in the middle of a frozen lake?
I don't think I'd have service.
Nonsense. But alrighty.
All right, so is it a date then? Monday.
Yeah, Monday.
And I think Taylor has a class, so we may need to tell him. Because I think he's in class currently.
Alrighty then. Oh yeah, let me open a new Word document and create.
If we have an email, don't we? Everyone has an email.
Nope, I actually do not email. Yeah, I do.
I send carrier pigeons as a hobby, so
That's an exciting hobby.
I don't actually, but that would be a cool hobby. Anyways, I'll see you guys later. We'll keep in touch.
See ya.
All right, bye.
Change.